All right, let's look at kind of a summary and some commentary on section T6A. A lot of what I know about this is right here on these slides and in those descriptions and everything, but I'll try to expound on some of it a little bit and just give you some real-world experience with some of this stuff. The resistor, it opposes current flow, and a potentiometer is a variable resistor used as a volume control. So basically that's like your volume control knob on your car stereo or surround sound or anything like that. And of course, those are also featured on amateur equipment that you can change the resistance basically through that volume control knob. And as a circuit component, it's known as a variable resistor. And capacitor stores energy in an electric field made of conductive plates and separated by an insulator. So if you are dealing with any kind of electrical components in amateur radio or in general speaking, you'll notice a lot of things like a computer, for instance. If you go to try to shut down and reboot a computer, and they recommend you unplug it, you leave it unplugged for 30 seconds or 2 minutes or however long they recommend. One of the reasons behind that is because the stored energy in the capacitors, not only can that stored energy keep enough energy in that component or in that device to make it retain some of its memory. So like if you're trying to reboot a computer, or radios are software driven mostly these days as well, you either pull the battery off of it or you unplug it from the wall or the power supply or something like that, and you leave it for a little while. You're giving those capacitors an opportunity to discharge to where that component will go completely dead and cold. And then you bring it back up, and like most things, the computers and electronic components, if you fully reboot something like that, a lot of times it will restart and start working correctly. And inductors store energy in a magnetic field and is constructed as a coil of wire. You'll see that in a lot of antennas, and of course also in other electronic components where you'll have coils of wire that serve different purposes. The SPDT switch routes one circuit between two others, and SPDT it's a simple on and off switch, or the SPST is rather. The SPDT, it routes one circuit between two others. Fuse protects circuits by melting when current is too high. Make sure that any of your equipment that you have, if you connect to a 12-volt power supply or whatever, that you have the fuses in place, you have the proper fuse of what it calls for. Like if you buy some used equipment or something like that, try to find the manuals. And that's real easy these days online. Even the oldest radios, you can find a scanned copy of a manual. And if you have fuses in that thing and it calls for a 1 amp or a 2 amp or a 3 amp, and you've got like 5, 6, 10 amps, something like that in there, then it could pass enough voltage or enough amperage through that fuse to burn up the piece of equipment. So make sure you want that to definitely be the weak point in the circuit, and that it will blow or melt or whatever like it's supposed to in order to protect your equipment. And then batteries, carbon zinc is not rechargeable. It's not mentioned in here, so is alkaline batteries that are not considered rechargeable. But you'll deal with nickel metal hydride, lithium ion, and lead acid. A lot of the stuff out there now, most of the HTs that I have lithium ion batteries. Whenever I first got in the hobby, there were NiCad or nickel cadmium batteries, and those things were notorious for having a memory. So like if you bought that battery and you charge it up, and it was made to last 6 or 8 hours or something like that, depending on how much you transmitted. But you would use that handy talkie or whatever for a couple hours, and then you'd throw it back on the charger. That battery would almost, it would kind of take on a memory of that and get to where it would it would get used to only lasting a couple hours. And that's just kind of how it would work out. So looking at the B section for semiconductors, a diode is a one-way current flow anode to cathode marked with a stripe, and forward voltage drop varies by type. Then LED emits light when forward current flows through it is a type of diode. So LEDs have been around for a long time in amateur radio and a lot of other electronic components. And now they're getting pretty popular in pretty much anything that we do. I remember several years ago replacing a lot of light bulbs in my house just for the energy efficiency of it, changing to LED light bulbs, and they don't get that hot or anything like that. A lot more energy efficient, and I noticed a noticeable drop in my electric bill. But now even cars and motorcycles and things like that are switching to LED light bulbs. One of the things I do is in my career is I investigate serious or fatal car crashes, and I recently worked an accident involving a motorcycle, and one of the things that we needed to try to determine is if the headlight was on when the motorcycle crashed. And used to be with halogen lights, you could send those off to the crime lab, and they could analyze it and tell you, one, if the light blows, they could tell you if it blew hot, basically, which meant that it was on when the crash happened, or if it blew cold, which meant it wasn't on, but the filament busted due to the impact. And pretty neat thing. Well, LED lights have sort of taken that away. You won't be able to, we can't test those things like that now, which the LED itself should, and I've got to do some more research on this, but if it goes out due to impact forces or whatever, it should be a little more visible to, or obvious to just the person looking at it, as opposed to having to send it off for any kind of analysis. A little side note there. BJT transistors, 3 terminals, emitter, base, and collector, and they can switch and amplify signals. FET transistors, 3 terminals, gate, drain, and source, controlled by voltage and electric field. So if you're in the automotive business like I used to be, and when I sold commercial tires, FET was a federal excise tax, but in this case, it's a term that we use for a transistor. A gain is the ratio of output to input signal and describes a device's ability to amplify. So this is something that you probably will use more in your amateur, don't want to call it a career because we don't get paid, and we're, well, of course, the term amateur, but in your amateur journey, you'll want to consider. So as you start to build your station, a lot of folks out there starting out new, I know they buy an HT or something like that, and then you start to get a feel for the hobby, and you start to get a desire to have a stronger signal into the repeaters that you like to work locally, and then you want to reach out and touch some others. So one of the things that you look at is maybe getting a dual band mobile radio and a power supply, and having that 50-watt output. Well, as you are antenna shopping and do your comparisons, whether you're going for budget and trying to get something off of Amazon, or you're going and looking at the ham shops and maybe looking to invest a little bit of money in something, compare the dB gain that each one of the antennas says that it has. And if you get a dual bander, most of them will have more on the 2-meter side than they do the 70-centimeter side, but they'll still be fairly decent. The ideal thing, if you can afford it and you can set it up that way, and you can take one radio and have 2 antennas, you can run through a duplexer or something like that. But if you can get antennas that are single banded, then you're going to have more gain from those antennas versus doing a dual band. But you can get some really nice, really strong dual band antennas out there that have a lot of gain to them. So if you're looking to save the space and take advantage of the dual band situation like we do, and that goes for your mobile antennas in your car. I had a friend that he would always exclusively put a separate 2-meter and 70-centimeter antenna. Even if he was just running one radio, he'd take the main output of that radio, run it to a duplexer, and it would separate those signals to that 2-meter and that 70-centimeter antenna. One of the things that you do run into with that, though, is that a quarter wave 2-meter antenna is also at an even wavelength on 70 centimeters. So that's one of the advantages that you have in using that dual band setup, is those components cross over. Now, if you were to get like a 5/8 wave 2-meter antenna, which will give you substantial gain, it's not going to work on the 70 centimeter side. So you would want the 2 separate antennas. And a friend of mine, he always exclusively did that. When I'm running mobile, I just want to put one antenna on there. I get a dual bander. But here at my base station, I actually have beams that use the same boom, but I've separated the inputs on them to where the 2-meter side and the 70 centimeter side are separated totally. Keeps the SWR down and gives you a little more gain out of those particular antennas by doing it that way. And then the T6C circuit diagrams. The schematic is an electrical diagram using standard symbols, and it shows connections, not physical layout or size. So basically, it's a not to scale diagram of the components inside your radio. Most every radio that you buy, anything above just your normal mobiles and HTs, HF radios, things like that, they should and typically do come with a schematic diagram of the radio. So if you really get into this stuff and can do, as the term I like to use is, you can do a little tinkering, and we're allowed to in amateur radio. We can experiment with our radios. Then that schematic could come in handy. If you purchase radios, I highly recommend, especially as you get into this hobby on the HF side, a lot of it, and maybe even the 2-meter 440 side, a lot of folks, they'll buy a radio and then they'll want to do some horse trading, and as I call it, and you'll want to trade radios around. So one thing that will help you maintain some value of your radios, if you decide you want to trade or resell or something like that, and try to get different radios and kind of make the rounds with radios, which there's nothing wrong with that. It's really fun to do. Make sure you hang on to that original box and all those pieces that come in it, and that schematic diagram and that manual. Even though you can download that manual online, and some radios manufacturers, they don't even put that in there anymore, or some component manufacturers, like an amplifier I had one time, you had to go online. But if you get that original stuff, hang on to it. That will make it a little more, if nothing else, it gives it a little curb appeal for folks that are wanting to buy it. And then you had the figure T1s, T2, T3. Here's the list of components on those. I highly recommend going back over the actual questions and looking at those a few times over and kind of getting used to what those are. One, for the purpose of passing the test, but also for the purpose of knowing the information. There's a lot of those that you will probably use some as you get more in depth in the hobby and you run up general class and get into HF, especially the symbol for ground and antenna and all that. You see that quite extensively with a lot of things that you buy or that you may have to do some user assembly with. And then variable components have an arrow through the symbol, and it means it's adjustable. So like a variable resistor or a volume control knob or variable inductors. And schematics show connections. They accurately represent how the components connect, but they're not their physical appearance. Like I said in the earlier, it's a non-scale diagram. Not only is it non-scale as in terms of measurement, but the depictions on the schematic diagrams are not literal to what the component looks like. It just has some attributes about it that you can kind of read into it and determine what that component is based on the symbols and the pictures and everything that they use. And then some of the component functions, the rectifier, it converts AC to DC using diodes, the first stage, and power supplies. So that's something that I mentioned in one of the previous sections that has been, if you're just brand new to electronics and this hobby altogether, this has been a big part of your life, whether you realize it or not. Phone chargers, smartphone chargers, any kind of electrical component, the powered speakers for your computer. There's a little square block that plugs into the wall, or it plugs in with the regular 2 or 3 prong connector, and then there's a little box somewhere in there in the middle of the line, whatever it is. I'm looking over here at my audio mixer and several other components. The world, a lot of these electronics world runs on DC voltage, and you may not realize it. DC voltage being like what's in your car. AC voltage is what comes out of your outlets. So you plug your TV or something like that in, maybe not the TV necessarily. I plug in my audio mixer over here into the 120 volt AC outlet, and something in there, either in the cord itself or the component, is going to convert that electricity into DC voltage. So that's the way that it does it, using a rectifier or its own little power supply. A relay is an electrically controlled switch. Small current controls larger circuit. So those come in pretty handy. Like it says, a small current controls a larger. One of the ways, or one of the things that you can do, depending on your configuration, the best connection for your mobile radios in your vehicle is directly to battery power. It's going to get all the voltage that it needs and all that. But what a lot of people like to do is they like to have the setup, and I like this too, to where when you turn that ignition key on or you push that button these days, you don't even have to have the key physically in the switch or anything. And the car comes on and your car stereo and everything else comes on. A lot of folks like to have their amateur radios, their mobile radios set up to where when you shut that car off, the radio turns off, and when you turn it on, it turns on. The voltage or the amperage supplied by the fuse box in your vehicle, you may not be able to find an open one that runs to ignition like that that's sufficient enough to be able to power that radio. So you can put that relay in circuit, have the relay run to the fuse box, and then the relay will break that circuit whenever it loses voltage to where the radio will turn off when the ignition goes off. You turn the ignition on and the relay receives voltage and it opens that circuit back up and turns the radio on. So you're still getting the benefit of the direct battery voltage and amperage, but you have a component there that takes a lot less power that you can plug in virtually anywhere, ride it in on top of something else if you need to in your fuse box. Some component, maybe your AM/FM stereo or something like that you know will turn off when and it's even neat where you have the retained power. When I worked for General Motors, we call it RAP, retained accessory power. So when you turn your key off, but your radio continues to play till you open the door or a certain amount of time goes by, you can actually connect into one of those blocks of your fuse box and have your amateur radio function the same way, to where it will stay on for a little while until your dome lights and all that other stuff goes out. Voltage regulator maintains a constant output voltage from a power supply. So that most power supplies these days, especially the ones that you can get with the higher amperage, the ones that you get for like your HF station, or I've actually got one that puts out about 45 amps. So I've got my 2 meter and my HF and everything connected to it. But you can adjust that voltage on that power supply, and my flex radio in particular takes a little bit of a bump up from that 13.8 volts. Yaesu radios are notorious. If you get a little bit of a low voltage feel to them, then they're just going to just fall flat on their face and shut off. So sometimes you may have to bump that up a little bit. But the voltage regulator is how you're able to do that. It's how it keeps it. If you bump it up from 13.8 to 14.1 or 2, I think is what I have to run for my flex radio. And that's not high enough to hurt anything else I've got connected into it. But that regulator, that's what keeps that from just going willy-nilly off the rails and going too high. Transformer changes AC voltage levels using electromagnetic induction. I know a lot of folks have heard of or are familiar with transformers that hang on your power poles and how it affects your home electric. Resonant circuit is inductor plus capacitor LC circuit, and it tunes up to a specific frequency. So resonance is something that you will definitely want to be aware of. Where it really comes into play in amateur radio is your antennas. A lot of times, if you have your antenna, if you use wire antennas like an HF, and let's say you're cutting that antenna for the 40 meter band, and you get it resonant somewhere in the center of that band, 7150, 7250, somewhere along in there, then your SWR will be low or lay flat on a particular frequency. As you get further away, it goes up. So that's one of the examples of a resonant circuit. Like for 2 meters, if you were to build, when I first got in the hobby, I actually built some of my own antennas using a few things laying around, and I used is a coat hanger antenna. I took a section of coat hanger and I punched in the main 2 meter repeater frequency that I used in my area at that time, and I want to say the length came up to somewhere around 19 inches or something like that. Do the formula for yourself and figure out where it actually comes in. You can convert meters, or you can use the 468 formula. But I actually did the math for that frequency. I cut that piece of coat hanger, section of coat hanger, to that exact length. I put it in a little connector, soldered it in, attached some coax to it, attached it to my radio, my SWR meter and my SWR laid flat because I had the exact measurement for that frequency, which made that that antenna resonant. So you'll deal more with that as you get into wire antennas and so forth with HF. And then shielded wire prevents unwanted signal coupling and acts as a Faraday cage. And that's probably more along the lines of some of the coax that you can use that will have that that shielding, that aluminum shielding in there. And that's one of the things you want to try to do that kind of helps, especially with your feed line, is if you have that shielded wire and you can contain that RF to the inside of that wire, then it'll more likely travel to the antenna and radiate out, as opposed to trying to turn the feed line into a portion of the antenna and it doesn't go exactly where you want it to. So that's some of the summary of section T6, and we're moving right along, getting close to the end here. So I hope this is all being helpful for you. And next up, we'll have section T7.